Okay, this chapter is good for understanding difference of cubes, but quite honestly, um, it's one of the less useful ones. Cubes. So it's good to sort of memorize the general formula, okay? And let's see. Let's see if it's, there we go. This is a good one. And I'll just put it on a new page here, and I probably should have prepared it beforehand. Just printing the screen. Okay, so I would use these two here as a reference point. And the benefit of this one is it reminds you that when the signs are negative here, they're all positive here. And when they're positive, as here, then the very first one here is negative. And that's really the only thing to remember. The other thing to remember is that this and a plus b, or x plus y, will be the first root. And then after that, it's the square of the first term, the square of the last term, and in the middle it's simply the two terms times each other, and the plus is dictated if it's a minus here, and the minus is dictated if it's a plus here. So that just takes time to get used to, but it very much helps to come up with this formula, or memorize this formula for difference of cubes. Now what this chapter does is goes about proving it with a factor theorem. So it starts with this one, and it just assigns a specific value and says, okay, we're going to use this as an example. We're going to show by graph that the only factor here is x plus 2, or root of minus 2. And then we're going to use factor theorem to show that the remainder is 0, that therefore it's a factor, and the only thing that's left cannot be factored further, and follows the formulas I just described. They even show the quadratic formula and show that you can't really come up with a clean factor or root. Then they go on to do it for a different one, and they show that in this case, it must be that one of the factors, and they go through it and they show the remainder is very much following the formula. Then they multiply everything by 2 just to get rid of the fraction, to show it follows the same formula. Then finally they do it again, but for a, they're just sort of skipping a and saying we're going to make a 1, and then you can pick any value of b and show that x minus b must therefore be a factor, and then use that b to determine that what remains is indeed the general formula. And it, of course, assumes a is 1. This is very useful for understanding where it came from. You will need difference of cubes and memorizing it. And then it gives a couple other situations where you have to watch out for situations where the first number could be factored. You have to watch out for situations where you can factor out a 7x here first. And here you just have to be aware that x9 is indeed has a cube root. It's x to the 3, so you just have to be aware of that. And so you just have to be fairly sound on your principles. It's essentially what this chapter is about. So I'm going to go on to the first questions. And the first questions want you to, the first one says, using solution C, which just made A1, determine the factors of this. So in this case, you just assume that the number in front of x is 1, and you're using your factor theorem to know that, okay, according to example C in the book, x plus b is a root, therefore x plus b is a factor, there minus b is a root. Then they want you to take the numbers in front of each term, which is 1, and here's the trick. What number is in front of x squared here? There's no x squared, so the number in front of it's 0. What number is in front of x here? There is no number in front of x, therefore the coefficient in front of it is 0. And finally, b is just b, because the cube root of that, is b cubed, which is just the last term, which is a number. Then you use synthetic division the same way. You bring 1 down, you multiply by minus b, you add 0 and minus b, you get minus b, you multiply that by minus b, you get plus b squared, you add it to 0, you get b squared, the b squared multiplies the minus b, and you get minus b cubed. These cancel out, and that's the whole point, is 0. So you've got 1 minus b and b squared, okay, which means that one of the roots, since it came out to 0, is indeed x plus b, and the other roots are x squared minus bx plus b squared, which fits exactly into our theorem. Notice that the terms in front were over x cubed, x squared, and x, and become x squared, x, and a number. And if you look at this, indeed, there's the plus symbol here. The original thing was x plus b squared, therefore this is going to be a minus, as it turns out it was. The first term here is this first term squared. The last term here is this last term squared. They're all pluses except for this one here, and the middle term is simply the root here times the root there. Or not the root, but these two terms times each other. So this also ends up proving our general formula. And they just want you to understand how to derive the general cube root formula. Then it goes through here. And keep in mind that factoring, you can factor either way you want. But for number 2, I'm going to use synthetic division as proof. Okay? So according to our factor theorem, x minus 8 is the cube root of both of those. So x minus 8 will be, x minus 4. 4 is the cube root of 64. So 4 is definitely going to, x minus 4 is going to be a factor, which means that plus 4 is the root. And then you put down the coefficients of each thing. Well, there's 1 in front of the x cubed, there's 0 in front of the x squared, there's 0 in front of the x, and there's minus 64 in front of the last number. Then you follow the same rules for synthetic division. You multiply the 1 times the 4, you add it to the 0. You multiply the 4 times the 4, you add it to the 0. You multiply the 16 times the 4, and you get plus 64. And you're always going to see, as long as you do the calculations correctly, that these will cancel out remainder 0, which proves that x minus 4 is a factor. Plus 4 was the root, x minus 4 is the factor. If that's true, this is the remaining on all the terms. The only time you have to be careful here is if there's a number in front of x, then you have to divide all those numbers by the number in front of x, but there's only 1 in front of x, which means what's remaining as the other terms is x squared plus 4x plus 16, which happens to be 4 squared, doesn't it? And therefore you can see in factored form, this are the two factors, and you can't factor this anymore. Also notice the plus sign here because it was a minus here, or rather it was a minus up here. Right here with this plus sign tells me this, when we factored, we're going to have a minus there. So just be aware of when the plus sign appears and when it doesn't. And there you go. That's how you factor using synthetic division. You're going to discover the coefficients for these cubics are always going to have this 0, 0 in it because there's no x squared and there's no x values in a cubic. Let's continue with this one. What do you think the basic root that we're going to be working with is here? Well, the basic factor we're going to be working with here is clearly x, which is the cube root of x cubed, and minus 5, which is the cube root of minus 25, which means the root that we're working is positive 5 in synthetic division. Oh, the last term here is minus 125. Synthetic division says I bring 1 down, multiply it by 5, add it to 0, multiply that by 5, add it to 0, multiply that by 5, and I get a positive 125, and sure enough, look at that, those last two terms cancel out, which means these are the coefficients in front of my last factor, which means it's x squared plus 5x plus 25. Notice that 25 is the same as 5x squared, which is why we could just use the general formula and put 5 squared here, but we just put 25 because that's the number that 5 squared is. Also notice the plus sign, and that's because, and it's actually because we started with a minus here. Now let's see what happens with this x plus 8. Notice a lot of the coefficients are going to stay the same, 1, 0, 0. And the last one here is 8. And I get those numbers because there's a 1 in front of the x cubed. There's no x squared, so that's a 0. There's no x, so that's a 0. And there's an 8, which is the number here. You have to have these zeros in here because they're there. They're just not visible. And lots of math things are there, but not visible. What is the cube root of x? It's x. What's the cube root of 8? 2. So according to our theory, this will be a root. Now, right away, I should be able to tell you from the general theory, we should expect to see an x squared minus 2x plus 4, or plus 2 squared, right? And that's the square of the first term, the square of the last term. The two terms times each other, but now we put a minus here because there's a plus here. Let's see if we get that with synthetic division. So what's the root of x plus 2? It's minus 2. Bring down the 1. Multiplied by minus 2, we get minus 2. Add it to 0, we get minus 2. Multiply that by minus 2, we get 4. Add that to 0, we get 4. Multiplied by minus 2, we get minus 8. The 8's cancel out. And sure enough, we're left with, as expected, x squared minus 2x plus 4, which is 2 squared. And you might say, how are you coming up with the x squared and the x and all that? Go back and visit synthetic division. We're essentially just putting the coefficient in front of that's in front of the various x terms. Those x terms are still there. We're just not including it in our calculation. But they reappear down here as one less than the term we started with. And this just becomes x to the 0, which is the number 1. So that's why this last one's a number. It's x squared here because we started with x cubed. It's x here because the middle missing term, well, there's no x squared. Yeah, the x squared was here, so the new term down here is 1 less x. And it was x here, and 1 less as an exponent on x becomes x to the 0, which is 1. So go revisit your synthetic division if you don't understand how I come up with these x's here. Anyway, that fits in with synthetic division, and we just continue. We just keep our main numbers that we're going to use over and over again. And we look at this next one. This next one has a number in front of it, and that's going to make things a bit more challenging. What's the cube root of the first number? 8x cubed. It's 2x. What's the cube root of minus 27? Minus 3. Which means we're dealing with this, which means we're dealing with the root 3 over 2. Right? 3 over 2. The problem is, at the end of this, we're going to have to remember to divide all our synthetic numbers by 2, because there's a number in front of 2, in front of x. Let's write down the last number here. It is minus 27. And again, I get that from this here. And actually now not a 1, I got to put an 8, because for the first time we have a number in front of x cubed. There's 0 in front of x squared, 0 in front of x, and then minus 27. So we start with an 8. So we bring down the 8. We multiply by 3 over 2, which is 24 over 2, which is 12. We bring that down when we add to 0. We multiply that by 3 over 2, which is 36 divided by 2, which is 18. Or you can look at it as 12 divided by 2, 6 times 3, 18. We add it to 0, we get 18. And then when we multiply that by 3 over 2, it becomes 9 times 3, which is positive 27. And we can see the last numbers cancel. Now the mistake you could make is writing it down as 8x squared plus 12x plus 18, because you're just taking your numbers from your synthetic division, right? Except that if that was indeed the factor, and I multiplied these first terms, 2x times 8x squared, I'd get 16x cubed. But what do I actually want? I want 8x cubed, which is why you have to divide all these numbers by 2, because this 2 number ends up multiplying all your synthetic numbers twice as high, or whatever number's in front of here, as you need. So that means I have to divide all these by 2, which is 4, 6, and 9, which happens, and it's 6x here, plus 9, which also happens to follow within our formula. 4x squared is indeed the square of this. 9 is indeed the square of that. And when I take 3 times 2x, I get 6x. So again, to write it more clearly, it is actually 4x squared plus 6x plus 9. And if you were to expand it, you will see and whenever you want to make sure you get the right number, you can expand it and see, because you might say, oh, that doesn't expand to 8x cubed minus 27. Well, there's the 8x cubed. Then it's plus 12x. I want you to remember 12x squared. I want you to remember that. Then it's plus 18x. I want you to remember that. Right here it's minus 12x squared, so the 12x squareds cancel each other. And then minus 18x, so the 18x cancels each other. That's why we have 0, 0 in the formula. And the last number, minus 3 times 9, makes minus 27. You will discover that for all properly factored difference or sum of cubes, that the even though there's an x squared here and an x, when you expand it, they disappear. They should cancel out. And if they don't, you factored incorrectly. So you can always multiply out and make sure you indeed get what you started with. On a test, when you don't have an answer book, that's what you should do. Okay, so let's look at the terms again. Now I'm going to start canceling out that first term, because it's not always 1 now. And we're looking at this one. And I'm just going to get rid of some of the mess here. Realize that we're dealing with these now. Okay, what is the cube root of 64x cubed? It's 4x. 4x times itself 3 times is 64x cubed. What's the cube root of minus 125? It's minus 5. 5 times itself 3 times will be minus 25, which means the root I'm working with here is 5 over 4. And if you don't know how to get roots at this point, you really need to go back and work on your understanding of factors versus roots. Now I have a 0, 0 up here, but what's the number in front here? It's 64. What's the number at the end? Minus 125. So I start by lowering 64, multiplying it by 5 over 4, or if you want, dividing it by 4, which is 16, and multiplying it by 5. Okay. When I get, and those numbers will straighten themselves out in the end. So 64 divided by 4, 32 is 16, times 5 is 80. Then I add it to the 0, I get 80. 80 divided by 4 is 20, multiplied by 5 is 100. When I add those, I get 100. And then 100 divided by 4 is 25, and times 5 is 125. So the last numbers cancel each other out. Now you might say, oh, those are way too big, and you'd be right. We now have to divide them each by 4. They all have to be divided by 4 to get the correct coefficients. So the correct coefficients are 8x squared plus 20x plus 25. And that fits in perfectly with our general formula, because 8x squared is definitely 4x squared. Oh, wait. What did I have there? I had 64, and that divided by 4 is 16, not 8. 16, not 8. There you go. Spotted it. 4x squared is 16x squared. Minus 5 squared is plus 25. And this, the plus, is because we have a minus here. And 4 times 5 times x is 20x. So that's just to verify that we got the right one. And notice using that, I was able to spot that I had the wrong number here. That's because 64 divided by 4 is not 8. It's 16. Okay, and then you just continue. The next one's pretty easy. But it's x cubed plus 1. I gotta go back and reconstruct my synthetic division here. And just put it in like that. And here we're looking at this one. Should be pretty easy, right? What's the cube root of x? X. What's the cube root of plus 1? Which means the root is minus 1. And what should I expect? What should I expect? I should expect x squared. I should expect a minus. I should expect x. And I should expect plus 1 here. And that first one is squared. And that's using the general formula, right? So that's what I should expect. Let's see what I actually get. What are the numbers in front of x cubed? 1. What's the number in front of x squared? 0. What's the number in front of x? 0. And then the last number? 1. I bring the number 1 down. I multiply it by -1. I add it to 0 again. I multiply that by -1. I get +1. I add it to 0. I get 1. And then -1s here cancel out. And sure enough, I have a 1 in front of the x squared, a -1 in front of the x here, and a 1 at the end. So indeed, those are, I've just proven, the factors are this. And if you expand this, you will again return to that, because the x squareds and the x's cancel each other out. And just keep going. We're just going to keep using synthetic division for solving these. This one is 27x, so that means the number in front up here is going to be 27, not 1. And the number here is +8. And what's the cube root of 27? It's 3x, 27x cubed. What's the cube root of 8? +2, which means this time my root is -2/3. Let's start by bringing the 27 down. Dividing it by 3, it becomes 9 times -2 is -18. I add that to 0, I get -18. I divide that by 3, I get -6. Multiply by -2, I get 12. Add that to 0, I get 12. 12 divided by 3 is 4, times -2 is -8, so the 8's cancel out. Now normally I'd stop there and use those as the coefficients in front of my new factor, but I have to remember they're each going to get divided by the number in front of x. So I'm left with 9x squared minus 6x plus 4, which makes sense because the general formula says I square my first number to put it there, I square my last number to put it there, I multiply them both by each other and put the opposite sign here. So it works. This is just getting you used to the connection. And it's important. I just wouldn't say it's as important as other things. Okay, I'm going to continue. We've done F, we've done G. What is the cube root of 1000x cubed? 10x times itself 3 times gets 1000x cubed. What's the cube root of 729? Now this one, I'm going to go with 16 because we're well above 12. But on your calculator, especially sometimes second function, you'll find either a cube root or an x to the y. For the x with the y, you press this, and then you put in the number you want to cube. In this case, I'm cubing, so I put in 3. And then I'm getting 9, which means the cube root of 729 is 9. Which means if I multiply 9 times itself once, I get 81. And times 9 again, I get 729. That makes sense. Which means I should expect 100x squared minus 90x plus 81 as my final factor. That's according to the generic formula. What are the numbers I put up here? Well, I put whatever numbers here, there, whatever numbers here. You should include the plus or minus too, is there. Just get rid of this x. So I got 1000, so I just bring the 1000 down. Multiply it by, I've accidentally erased my factor. The factor is actually, what is the factor now? What is the factor of the thing down below? It's -9/10. Oh, sorry, the root, not the factor. So if I divide my 1000 by 10, I get 100. If I multiply that by -9, I get -900. If I add that to 0, I get -900. If I divide that by 10, I get 90. -90, and if I multiply that by -9, I get positive 810. If I add that, I get 810 to 0, and then when I divide that by 10, I get 81 times 9 is indeed, minus 9 is indeed minus 729, which means I got exactly, and you might say, but that's not the numbers you expected. Yeah, but don't forget, I got to divide them each by 10. Which means the numbers, the last root is actually going to be 1,000 divided by 10, 100x squared. Minus 900 divided by 10, minus 90. 81 divided by 10, plus 81. And there's an x here, and an x squared here. And sure enough, those are the exact numbers I expected. And the last one, you have to know what is the cube root of 216, and if you don't, you can take your calculator out. You can also take a guess. 12 is 144, 13 is 169. So 14 is not 15, maybe 16? 16 or 14? I'm going to go with 14 because 4 times 4 would make a 16. So let's just see. 4 times 4 times 4 is 64. I don't know what I was thinking there. I meant 14 times 14 times 14. Woo, way too big. Yeah, so I'm thinking square roots. That's my mistake. So we're just going to take, instead of guessing, we're just going to take 216. Now my second function also has a cube root right here, 6. So that means the first term, the cube root of 216x cubed is 6x, and the cube root of minus 8 is minus 2. Which means the root I'm working with is 2 over 6. What's a simplified version of 2 over 6? 1 over 3. What are the numbers I'm working with here? I'm working with the first number here and the minus 8 over here. Then I just start with synthetic division. I bring the 216 down. I divide it by 3, which is 72, and multiply by 1. Then I add that to 0. I get 72. When you divide that by 3, it's 24. Then I add it to 0, 24. When I divide that by 3, I get positive 8. And the numbers cancel out. But I'm not done. I have to divide each of these by the magic number 6. So if I divide them each by 6, 6 goes into 21 36 times. So I get 36x squared. 6 goes into 72 12 times. So I get plus 12x. And 6 goes into 24 4 times, so I get that. And don't forget to put the square right here. And sure enough, that falls right within the formula. These are my factors right there. And that's how you do it with synthetic division. Now, at a certain point, your teacher's going to tell you if you want you to synthetic division or the general formula. At this point on, I'm using the general formula because we've proven what goes on. Now, they're going to throw a couple tricky ones here, so we're going to try to use both to show what's going on. But according to me, the cube root of 64 is 4x. 64x squared cubed is 4x, and the cube root of 27y cubed, and we'll maybe use synthetic division here, except I don't think it's going to work, is 9y. So we're just going to use the general formula, which says that 16, oh, it's 3y by the way, which says that 16x squared, because I'm going to square the first term, and the last term is going to be 9y squared, and the middle term is going to have a minus because it was a plus in the original, and it's going to have 3 times 4, which is 12, and x times y. So it's going to be like that. So according to my theory, there's going to be a square and a square. So it's very important for you to predict, if you can, what you're going to get. Let's see if we can do it synthetic division style. The only problem I could see is that 27y cubed should be treated like a number. And I think we're going to end up with some weird xy's. Well, we'll try it anyway. So 64, 0, 0. I'm going to say 27y cubed. Because we're treating the y like a number, I think. We'll see how it goes. And what's the root? The root's very tough to understand. It's minus 3y over 4. That may not work out because I can see in my first term I don't have a y. Right? We'll see how it goes. Then we'll put our synthetic division bars down. This might not work, by the way, just so you know. Bring the 64, divide that by 4. I get 16 times 3 is minus 48y. When I add that, I get minus 48y. When I multiply that, interesting stuff. Actually, this might work. When I multiply, I think I just had to skip the y. When I multiply that by, divide that by 4, I get minus 12 times 3 is plus 36y. When I add that here, I get 36y squared, by the way. It's y squared now, if the y's in there. And then the last term divided by 4 is 18, 9 times 3 is minus 27 y cubed. So it might actually work out. Yeah, I think it will, because we're still going to get this. And what do we have to do with each term? We have to divide it by 4. Which means this becomes 64 divided by 4, 16, which we have, x squared. And there's an invisible x here. When we divide this by 4, we do and get 12, negative 12, which we have. And we have the y there, but you throw in the invisible x. And this last one is indeed divided by 4, we get 9. So it actually worked out fine using this as the root. So you're just treating y like a number. And it makes sense because you can't really have two x's in a formula, if you know what I mean. And again, they're just getting you to exercise your brain. This one's interesting, and you might go, what? That can't be root out, but it's back. They want you to spot the tricky ones. So if I can take 3x out of both of these, I get x cubed minus 8, right? And we've pretty much done x cubed minus 8. You just do the normal roots of this, and you just remember to include the 3x as one of the factors. So you'd be left with x minus 2, x squared plus 2x plus 4, like that. And that I'm just using the general formula because we've already done x cubed minus 8. The next one I might botch. So let's go to this one first. What is the cube root of x to the 6? Well, when you multiply x squared times itself 3 times, you will indeed get x squared. And what's the cube root of 64? It's 4. Now here's the problem. We can't use synthetic division for this because x squared plus 4 doesn't have a root. So we can't use it like that. It's well below the y-axis. X squared equaling minus 4 is impossible. So you would have to just use the general formula, which means I'm going to have x to the 4 here, plus 4x squared here, plus 16 here. And you should be able to multiply them out and get that. That's the whole point. So x to the 6, yep. Now I want you to remember this. Plus 4x to the 4. So plus 4x to the 4. Plus 16x squared. So plus 16x squared. Oh yeah, I forgot. This has to be a minus because this is plus. We're going to change that. And we're just going to remember to start. We'll start again, okay? X squared times minus, okay, x squared times x to the 4. We got it right there. So that's what we want. This next one is minus, not plus. It's minus 4x to the 4. This next one is plus, which we have. This one here is plus x to the 4, and I have minus x to the 4, so they cancel out. This one here is minus 16x squared, and I have plus 16x squared, so they cancel out. And finally, that times that is 64, which we have. So you can see all the x squareds and whatever cancel out. So in this case, because I can't take a synthetic root of what I want, I can instead take expand it when I'm done to make sure I get back to where I started. And that's how we should do this next one. Now this next one's tricky. And here we're just going to use our factor theorem. And you're going to say, What's our factor theorem says? Well, it says you take the cube root of this one, x plus 5, and then you subtract the cube root of the second one. What's the cube root of 2x plus 1 cubed? It's 2x plus 1. And you put a double bracket around both of them to say we're working with extra brackets here. Now, right away, I can say x plus 5 minus 2x minus 1. Why did that minus plus 1 become a minus? Because the importance of brackets is to show that this is an entity on itself. I have to subtract that entity. So that's like having minus 1 multiply through this. So both these terms become the opposite based on that. So when I get x minus 2x, I'm left with minus x. And when I get 5 minus 1, I'm left with plus 4. So I'm actually left with this. You can also rewrite that. You can also rewrite that. And I'm keeping that there for a reason. You could rewrite it as this. And you'll often find your book will rewrite it. Even though I don't think technically they should, they will. So we know that that is essentially the first factor. Now here you could take the root. You could expand all this, find out all the terms, and use plus 4 as a root. Why is it plus 4? Because minus x plus 4 is the factor. We make it equal to 0. We get minus x is equal to minus 4, which means x is equal to 4, which means the root must be 4. Sure enough, if you put 4 into here or here, it makes 0, which is the goal. So that's the root, is 4. And the only way you could factor it into this is if you expanded it. Now, I might do that anyway. But instead, I'm going to use the factor theorem, and I'm going to guess what I should have. Well, according to and I might screw this up because there's lots of this. According to the factor theorem, I should have the first term squared. I should have plus the first and the second term times each other. And then finally, I should have plus the last term squared, right? That's what factor theorem says. And I actually might want to raise it just so I have a bit more room. There we go. So what's the first term? It's x plus 5, and that's going to be squared, according to factor theorem. And then it's the two terms with a plus between them because it's opposite the minus, times each other. And that's just the normal formula. And then the last term, which is 2x plus 1 squared. And you just got to remember to put a square here and a square here. Now, before I can write down in front of this what its I could just technically write it like that, but you can see it's long. What your book will want you to do is expand this, expand this, expand that, and then add and subtract all your like terms. Let's give it a shot. And you should know your expansions very quickly. What's x plus 5 expanded? It's x squared plus 10x plus 25. Fortunately, there's pluses between all of this. So that's your first term expanded. What's your second term? Plus 2x squared, right? Plus x plus 10x plus 11x. And 5 times 1 plus 5. So that's your second term. What's your third term expanded? 4x squared, right? Plus 4x plus 1. You should know automatically how to expand anything like that squared very quickly. Let's add our like terms. X squared plus 2x squared plus 4x squared is 7x squared. What's our, and I'm going to just put a square there. How many x's do we have? We got plus 10x here, plus 11x, it's plus 21x. And we've got plus 4x, so plus 21x, plus 10x, 21x, 25x should be the middle. And I could make it an error here. It's very easy to make an error. And finally, what's 25 plus 5 plus 1 plus 31, which means the factor I would put in front, in front of this is this. Let's just get rid of that for now. and this. So your book should say what I've written here. Now, to test out if this is indeed the correct factor, you'd have something like Symbolab expand all this and expand all that and see if they equal the same thing. But let's just see what the book says. The book says this is the answer. Did we get it? Yeah, the second one. So we got it. And that's simply by knowing the rules for a difference of cubes. Now, since I do know that the book gave me the same answer, I'm not going to expand on the C. But you can see that that one looked hellish, and it's really just about applying the same rules over and over. Then they just want you to practice, and in this one I would just say use your cube root rule, and that means you just got to find the cube roots of these numbers, right? That one's easy. That one's easy. Don't forget you found it here. Don't forget you found it here. Don't forget you found it here. That's new. And this you just found it here and here. And this you found it here. So you just got to kind of remember some of them. You can also write them down somewhere and hope maybe your brain will remember it. Get used to your calculator as well. We already did 216. I think it was 6, right? 1,000's cube root is 10. 125 is 5. Minus 512 is equal to, what is 512? I think it wasn't 15. 8. Interesting one. So minus 8. 1331 minus 11 minus 11. 343. Oh, I already did it up above. It's 7. 512 I already did. 1331 I already did, but 1728 I didn't. This way you don't duplicate your efforts. Now whether it's minus or plus, it depends what it is in the equation. But going from A, here's what I can quickly do. X squared plus 7x, because it's the opposite sign. And like that. So all I'm doing is using the factor theorem over and over again. Or the general formula. And I'm just remembering the rules for pluses and minuses. At any time, you can take the root of this and practice your factor theorem, and you can almost see right away why it works. So 1/6, they're going down by 1/6. These are going up by multiples of 7. So I'm not going to bother, just so long as you understand. And here's C, x plus 10. So I'm going to be left with x squared plus, minus 10x, because they're added up above, plus 100. I'm just using the general formula. D, it's 5x. The main root is 5x. And what was 512? It was 8. So I'm talking about 25x squared plus 40x plus 64. And I just got to make a bit more room here. And I just got to remember to put a square there. And I'm just using the general formula. You can use synthetic division to prove it to yourself. The cube root of 131 is 11. And then I just go and use the general formula. I square the first term. I multiply the two together and make sure it's a plus symbol, and then I square the last term. .343 we discovered on the left, this cube root is 7x plus 3 for 27. So I get 49x squared minus 21x because it's a plus, and then plus 9 in the end. And don't forget to put all your squares in there. And now we're going to go on to G. All I'm doing is taking the general formula, finding the main root, which is 8x plus 1 here in G, squaring the first term, multiplying the two terms together and putting a minus because it was a plus, and then squaring the last term. And then I'm going on to H. The cube root I've already discovered for 1331 is 11. So 11x, 1331x cubed is 11x. 1728 I discovered was 12. So to figure out the second roots, here I'll just do it again. There we go. It's square the first one, x squared, negative, and the two times each other. What's 112 times 11? It's 132x, and then the square of the second term. Boom. And the last one, they've put it in different order just to have the negative second. I mean, I'm just going to put it in the right order. So we discovered minus 1331 is that. And up above we discovered 512 is 8. Then I just simply square the first term, multiply the two together, and because there's a plus there, not a minus, I'm putting a minus. But when I multiply 8 times negative 11, I get negative 88, and it becomes a plus again. And then 8 squared is 64. Now, you might think that screws it all up, but it doesn't. You can reverse the terms and get the same answer. Okay. And that's all three of them. Obviously, you could go back and take the root of this and put it into the coefficients to see, but notice the connection. This is going up by 10, which makes sense. This was 1/8, so each number should be shrinking by 1/8. It does. The root was negative 1/8. This root is negative 12 over 11, so everything should be shrinking or multiplying by 12 over 11, so slightly increasing. If you multiply this by 12 over 11, you'll get 132, and when you multiply it by 12 over 11, you get 144. And then same with these. This is 8 over 5, so it's multiplying by 8 and dividing by 5, so it's going to go up. So sure enough, 8 times 25 is 200, and then when I divide that by 5, I get 40. That's how it works. And this is going up by a factor of 11 over 4, so each thing. This is negative 3 over 7, so that's almost a half. So you can see it's slightly more than a half each time. But sure enough, if I multiply 49 by or divide it by 7, I get 7. Multiplied by 3, I get 21. 21, if I divide by 7, I get 3. And multiplied by 3, I get 9. That's how you know those numbers are right. But you can go ahead and do synthetic division if you want. I'm not going to, because I've demonstrated both techniques. Number 5 is a little bit tricky. I'd like to do number 6 first, in case I screw up number 5. Jared claims, Jared's got too much time on his hands, that this equals 1. Now there's two ways you can go about this, and I want to show you two ways. He's essentially saying, look at that. What is that? That is a sum of cubes right there. What is that? That's a difference of cubes factored, isn't it? So really, That's a cubed plus b cubed on the first one. And the second one is a cubed minus b cubed. How do I know? Because I can see the terms cubed, 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 and cubed. Because I can see the terms here match the difference of cube rules. There's the square of the first term, the two terms times each other in the opposite sign, and the last term squared, and there's the basic root term. Same for this one. And it's all being divided by this mysterious 2 over 3, 2a cubed, like this. Right? But you can rewrite that, and notice there's a plus in between them. So the first two terms are multiplying each other, and the second two terms are multiplying each other. You're allowed to divide this like this. This is a rule of math. There, I've turned it into two fractions. And that's because anything added together, you can divide up, and so long as you keep the denominator the same. You can do it again. And again. So long as you keep the denominator under the right fractions over and over again. So essentially they're all being added, and this last one's going to be divided. So he's claiming that it's all equal to 1. Okay, what cancels out here? The a cubed divided by a cubed leaves 1, and there's still 2 down there. So I'm left with 1 over 2, right? What cancels out here? Nothing. Nothing. So we're just going to leave it as it is. It's just as it is. What cancels out here? Well, the a cubed cancels out, and I'm just left with plus 1 over 2 again. And then finally, this last term cancels out nothing. I just leave it. But let's rearrange. A half plus a half plus b cubed over 2a cubed minus b cubed over 2a cubed. They're the same terms, right? Just one's plus, one's minus, right? It had a minus in front of it. So they cancel out. What's a half plus a half? It's 1. Now, you could do it like the way I just did it, which makes a lot of sense, or you can do it by expanding everything. They'll all have a terms then. Some of them have a cubes, and some of them will disappear entirely, and you get rid of the cubes. And then whatever numbers can be divided by 2, you can divide them by 2, but you'll still end up with the same thing. All that will happen here is when you expand it, it's the same thing I started with, a cubed minus b cubed. Like when you expand that, you'll get exactly what I started with. And then you can do this process. I agree with Jared, but Jared's got too much time on his hands. Now, I'd like to go on. This is a weird one. I'll get back to 5, just because there's some stuff in 5 that's bizarre. 1739 is an interesting number. It's the smallest whole number that can be expressed as a sum of two cubes in two ways. That and that. Use factorization for the sum of cubes to verify that. Okay, let's just start with the first one. If you ignore that it's 9 plus 10, according to our sum of cubes, I should be left with 9 plus 10 as the base cubed. And then it's going to be multiplied the first term squared, the two terms times each other, and it should be subtracted because they're plus, they're sum, and the last term squared. If I add up the first two terms, I get 19, and 19, 81 minus 90, or not minus 90 plus 100 is plus 10, and 81 plus 10 is 91. All I need to know now is what is 19 times 91. Lo and behold, it's exactly what they say it is. It's 1229. Let's look at their other one. This is a sum of cubes again. What is the first term? What is the cube root of the first term? 1. What is the cube root of the second term? 12. What is the first term squared? 1. Subtract, what's the first term times the second term? 12. What's the second term squared? 144. What's 1 plus 12? 13. Times. What's 12? 144 minus 12 is 132, and plus 1 is 133. So the question is 13 times 133 1229? 13 times 133 is indeed 1229. So we were able to use this to determine that it is indeed correct. Let's go on to the next one. Prove. Ooh, I don't know if I might jump up to number 5 for this instead of this one. So this is a sum of cubes there, but they're multiplying it by what looks like the factor of another sum, half a sum of cubes. Then they're adding a mysterious number for some reason, and they're saying that's equal to the square. Well, instead of doing it, let's try to find what sum of cubes this represents, and what half of sum of cubes that represents, right? And I'll show you how to do the second part. It's clear to me that the sum of cubes in the first one is x to the 6 plus y to the 6. And that's because I can see in here that if these are the base roots, we're talking about the cube. And if so, this should be the square of that one. This should be the square of that one. And this should be times, the two terms times each other with a minus sign, which it is. Which means we're dealing with that sum, x to the 6 and y to the 6. Now you might say, well, that one's not complete over here. How would I do it? Well, now we're going to decipher what we think is, this is definitely a part of a sum of two cubes because it has a negative. And just looking at that, I can take the square root to try to figure out the original root. What x times what x exponent, the same exponent, is going to be x to 12. Well, you add your exponents. So that means x to the 6. X to the 6 times x to the 6 is that. What is what is the square root of that? Y to the 6. Now you might say, why am I doing square root? Because remember, in these terms, they're this terms to the base, the root term, times itself. So I'm looking for the square root. Now I have to figure out what's the cube root of that. What is y to the 6 times y to the 6 times y to the 6? Well, you add the exponents. It's y to the 18. And same with x to the 6. It's x to the 18. So this second one, I'm essentially multiplying it by x to the 18 plus y to the 18, right? Except that's not the complete cube root of this thing. I'm missing, in this part here, I'm missing the base root, which we figured out was x to the 6 plus y to the 6. And that's the hint, is it matches the first one. I'm missing this part. It's not there. It's not up here. I don't see it. I don't see it in the second part, which means it got divided out. Which means it got, since they're multiplying each other, if I divide both sides by this disappears, and I'm left with that. So I can technically rewrite half of it, and if you can't understand how I'm doing that, like this. And you might say, I don't understand how you got that, but I want you to notice, okay, what's missing? This part, right? From that's the whole thing. But that whole thing expands out to this, is what I'm saying. But they don't give us this, right? They only give us this part, which means I could take the original root, expand it all to this, and if I take the original root and divide it by that, it will get rid of that and just leave that. So that means I start with the full root divided by, ironically enough, this. And then it's saying I've got to add on this thing at the end. Whew. I don't know if I'm going about this the right way, but I can immediately see that if it's this here is that, and this here is that, because I divided out the part that's missing, that these two cancel out, and I'm left with x to the 18 plus y to the 18 as the roots, and I've got to add this. Wow. Then I've got to say, right there I got a problem. Because this part here I'm saying is that part, once this cancels out with it. Oh yeah, I'm only missing, no, I'm saying expanding that will cancel out with the missing part and leave this. But the problem is this is already that. Using the factoration for the sum of the cubes. Interesting stuff. So my only problem here is I don't really need that. I can see that I have x to the 6 here plus y to the 6 as the missing terms for that, which is x to the 18 plus y to the 18 divided by this to get just that. Huh. But then this should cancel out with all of that. And so that's something I don't need. I don't think it's true. Well, I guess it's true because they're asking. So I must be doing a fundamental mistake. Let's look at this last term. If I expand that, I'm essentially going to be x to the 9 plus y to the 9 times itself. And I'm going to get, there we go. I'm going to get x to the 9, x to the 18. Yeah, I do have it. This is going to be the middle term when I expand that. Okay, so when I expand this, I'm left with x to the 18 plus 2 times those two terms, which is x to the 9, which is essentially this. And then the last term, which is plus y to the 18. So this is this right term right here. If I expand this, this is what I get. This left term, I've already determined that this is the sum of x to the 6 plus y to the 6. I've already determined that from my knowledge of sum of cubes. That's precisely, if I factored this, that's precisely what I would get. So I'm going to go reverse it and put that. So essentially I'm replacing all of this with that. This I can see is partially the x to the 18 plus y to the 18. Let's bring that up. Except it's missing. If I were to take the sum of roots for that, it's missing this part. It's missing this part. So if I were to find the sum of roots of this, I'd get this times that. So that's what's missing. So if I just want to have this, I would have to divide both sides by this to cancel it out on the right side, and like this. In other words, if I expand this, I will get all of this, and then if I divide this out, I will get rid of that part. And I'll be left with what I had there. So that means this part here could be replaced with this. It's clear to me that if this multiplies that, the bottom will be canceled out. I'll be left with this plus that plus this, which happens to be the same thing as the expansion of that. Hope you follow that one. If not, I'll do a more detailed one. Some students would argue that if you know how to factor a sum of cubes, then you do not need to know how to factor a difference of cubes. Explain why you disagree or agree. I agree. And here's why. Suppose I only know how to factor a sum of cubes. And let's take this. We're going to take 9x cubed and 16. No, and 27. There we go. I know that the sum of cubes of that is 3x plus 3. And I'm going to be left with 9x squared minus 9x, which is what happens when you multiply them, plus 9. I probably chose bad numbers. Let's choose, instead of 27, let's choose 8. That way you can see a difference in the numbers. Plus 8. So if we know how to do this by the book, we know we're going to be left with 3x plus 2. And we're going to have 9x squared minus 6x, there we go, plus 4. But plus 8 here is the same as, this is the same as, plus, instead of plus 8, I'm going to put a minus 8. That's the same as plus 8, minus 8. Or what would be a better way of doing it? You could take a plus here. Well, you could rearrange it, too. You can just say, well, that's the same as minus 8 plus 9x cubed, right? Now you just take the cube root of that, which is minus 2, plus the cube root of that, which is 3x. Now we're going to find the square of the first term. The two terms minus, but times each other is minus 2 times minus 3, so that becomes plus 6x. And the square of the last term becomes 9x squared. Now we're going to rearrange it. It becomes 3x minus 2. And it becomes 9x squared plus 6x plus 4. All I'm doing is rewriting it. So instead of the correctly sum factored version here, I can do it here. And lo and behold, I can also rearrange this top as, instead of 9x plus minus 8 plus 9x squared cubed, I can rearrange it any way I want because they're all being plussed and minused as that. Suddenly I've figured out the formula for the difference of cubes. There, that's the easiest way to explain it. Extending the number 1 tune question called a taxi cab ride. Use the internet. Are there any taxi cabs? So what are they? Do that in a second. So let's go back to number 5. And actually, I'm going to skip that last one. You can internet search on your own and discuss it with your teacher. It's certainly not math, which is what I'm trying to teach. Okay, so if your teacher wants you to know the taxi cab number, you go ahead and discuss it. You might say factors are impossible, except 1 over 3 times 1 over 3 times 1 over 3. 1 over 3 is all the same number. They're equal to 1 over 27. So that means the root of that first term is 1 over 3x, like that. The root of the second term is minus, because it's a minus. What do you think the root of the top number is? The cube root, 2. cube root of the bottom number, 5. There, we have our first terms, 2 terms. At the end, we're going to multiply by some number to get rid of all these fractions. And I'm just going to put this in the corner. There. Okay, what are our second terms? Well, the first term squared, which is 1 over 9 x squared. Right? That's the first term. What's the second symbol? It's going to be a plus. What's the two numbers times each other? Well, there's 2/5 times 1/3, which becomes 2 over 15x. You might say, how come it's plus? They were minus. Because remember, when it's difference of cubes, this symbol is a plus, and this symbol here is a plus. Finally, what's this last term squared? 4 over 25. Now, the book generally, this is the correct factors, but the book generally will hate having fractions. I'm just going to see if it cares if we have a fraction or not. So this is number 5. Number 5 does not care if we have fractions. Some teachers will want you to get rid of fractions, and I'm kind of one of those people, but we can see that we indeed got it right. Okay, but if you're going to get rid of the fraction, you'd have to multiply all this. So this would multiply by 3. And you essentially have to put a big giant bracket around it and say, I'm going to multiply. Well, you should only have to multiply the first term times 3. It's a good question. So if I divide this by a third, what number do they all have in common? Let's look at the first one. Don't bother. The book just is fine with this. Your teacher's not going to want you to go past this. But generally speaking, you would multiply this all by 15. And since 25 can't be multiplied by 15, you'd have to even go further. Find a number that 9 and 25 can be multiplied by and can divide into to essentially get rid of all these denominators. I think if I just multiply 15 times the first one, I'm left with 5x minus 6. But it doesn't work for the other ones. All right, well, the book accepted the fractional answer, so we'll just move on from there. So we did this one. This one looks tricky, but you just treat the first number like anything. You just keep the negative. So you got to take your calculator. Oh, right there I can see there's a trick. I'm going to discover these can't be factored, but I know that 64 can, and 64 is half of that. So if I factor out a negative 2x squared, the first term becomes positive 216 x cubed, and the second term becomes positive 64. Right? I also know that 216 has a cube root of 6. Now, how did I know to factor out 2x squared? Well, notice this is x to the 5 and this is x to the 2, which means you can bring an x to the 2 out. And then you just kind of know, oh, I know 64 has a cube root, 128 doesn't. I wonder if I divide them both by 2 if I'll get a cube root possible number, and you will, 6. So now you just leave that minus 2x squared in front, and your first term is 6x, and your second term is 4. So that's the first factor. The second factor is the square of the first one, 36x squared, a negative, and 2 of them times each other, 24x, and then 4 squared. That's just following the rule of sum, and don't forget to put your square here. And there, you've correctly factored the second one. Now you can always go and check and say, did I get it? And let me just see if I got it here. And according to me, it is this one, right? Get rid of that fraction. Ooh. Oh, you know what I did? Oh, I see what I did. they took out even more. They took out 16 instead of 2, and you'll notice that this is half, and you notice that this is a quarter. So I only took that much out, but now that I look at it, I can see that it can take out another 2, 2, 2. Yeah. So right here, had I instead taken out minus 16, 432 would have become 27, and 128 would have become 8. So I would have had 27x cubed plus 8, which would instead lead to a 3x plus 2, and thus all these would become that. So they just factored out a bigger number. This is still correct, but not what the book wanted. Okay. Didn't we do all these? No, we didn't. So they're doing it again, and they're making us expand, but I thought we did something very similar. I guess we didn't. I think I did I did 5C already. So I'm going to go straight to D. Which is this. Just make sure I did it all right. I'm sure I did it already. Okay. So this is the last one. So we have to find the cube root of 512. It's 32, which means the root of this is 1 over 32 x cubed minus 32. And that's because this is the cube root of that, and this is the cube root of that. Now you would just square the first term. And for that, I'm going to have to find out what 32 times 32 is, because it becomes 1 over 1024. So I'm going to have to remember that. So it becomes 1 over 1024 x squared. And don't forget to put your little fraction denominations here. Then the terms times each other with a plus sign become the 32's cancel out, and I'm just left with plus x plus, oh, and don't forget this is not x squared, it's x to the 6, because I started with x to the 3, and x to the 3 squared is 3 times 2, x to the 6. The next terms, the 32's cancel out, and I'm left with a plus, because even if they cancel out, it's still got to be a plus symbol, x cubed. That's what happens when you multiply those two terms together. And then the last term I'm left with is minus 1, or plus 1024. And so let's just see if we got it. It'll be right here. Oh, look at that. They found another, they spotted another cube root. So what they did was they factored out even more before they did it. They factored out this. And they reduced this by a factor of 4. And this by a factor of 4. By factoring out half minus 2 first. Or another way to look at it is this is another cube root. I think they did a mistake with this 1 over 64 though, because, oh, you know what? I'm the one who did the mistake. It's supposed to be 1 over 6, right? The cube root of 512. Eight? Okay, what's 8 times 8 times 8? 512. I'm the one who did the mistake. It's supposed to be 1 over 8 here. And it's supposed to be minus 8 here. Minus 8. 8 times 8 is not, I'm not looking for this, so that's a big mistake by my part. 64. The 8's do indeed cancel out though. which explains why I got the x cubed correct. And this is not 1024, but 8 times 8 is indeed 64. So I had all my numbers wrong because stupidly I put the basic roots wrong. However, they noticed that 1 over 8 minus 8 can be factored again. And they factored it again because that is now a difference of cubed roots. And your teacher's probably going to do something tricky like that sometimes. And the root of that is 1 over 2x minus 2, which we see right here. And then we're left with 1 over 4x squared minus x plus 4, and this is a plus. And we see that right there. So the only thing that happened is, one, I didn't correctly write down the cube root of 512, and two, I didn't factor out the second factor. But there you go. Pretty much it.